Hello. So today I want to clear up a common confusion in engineering mechanics between stress and pressure. So at first glance, they look identical, but in reality, they are different, right? So for both of them, stress or pressure, they are identical, but again, they are different. They both have the same formula, which is the force divided by area, right? And they have the same unit of Pascal, P. That's Pascal for both of them. So, but then the question is, are they really the same? Stress, it's not pressure. Now, we clearly know that yes, they have the same units and all. But again, one clear distinguishing factor is that pressure usually describes a force acting on the surface of a fluid. Pressure usually describes or a force acting on a fluid. I think that's the key distinction, fluid. That's for pressure. Now, if we have, let me give some examples I can easily think of. Okay, one is air inside a tire. Oh, I think some people spell it this way. That way here. Then a tank, water in a tank. You have a tank like this, and let's say it's this way. And you have some water in it, right? Maybe somewhere. So that the forces acting on the body. That's pressure on the body. That's pressure. Hydraulic systems. You don't say stress, you say pressure there. So that's pressure basically. Then another key part is pressure. It does act. Pressure acts in all directions in a fluid. So if let's say we have it like this, hypothetically speaking, pressure acts in all directions because this is 2D, but that's to explain what it is basically. So that's the key idea. So uh, one one key idea is we talk about pressure. It's talking about a fluid. Two, acts in all directions. Acts in all directions. Right. So considering the fact that it acts in all directions, then technically it does not depend on any direction. So doesn't depend on well, it doesn't depend on direction basically. That's key idea for that. Now let's talk about stress. So for stress, as we've previously mentioned, stress is also force over area, right? Yeah, either P or F, that's fine to define that. But then, how do we define stress? Stress is the internal resistance. Internal, that's another keyword. Internal resistance developed in a solid material. Internal resistance developed in a solid material. For pressure is fluid, but for stress in a solid material. So if you have, for instance, let's say a bar, so right, then we have like a smaller end, or this is not necessarily taper, but a smaller cross section of this. Let's say this one, probably two. One is greater than two, right? So if you apply a force here, that's not good. If you apply a force here at this point, or a force here, then there'll be more pressure at this bottom, right? Pressure at this bottom compared to these parts, right? So that's the internal resistance. Of course, as you're applying that, there's some force going upward too. So that's what we call stress, internal resistance. So stress typically tells us how the material internally resists deformation. That's how it resists it. So let me write that. So internal resistance to deformation. That's stress. Now, for stress, like unlike pressure that it doesn't depend on direction, stress depends on direction. I mean, if you the force you're applying here, of course, affects the stress you receive here, right? If this force is applied this way, I mean, there'll still be stress here, one way or the other, but it will not be maximum compared to when it's perpendicular, right? If you apply stress here too, it can be like a shear stress at this ends. The stress at this point will be different compared to here. So it's directionally, it depends on direction. So another key point is, okay, it depends on direction and also the orientation, right? Because, yeah, the orientation, which I just explained, basically. So just to summarize, the key differences: pressure, so the external force per area, usually acting on fluids and and also acts in all directions. Pardon my bad handwriting. An external force acting an external force per area acting on fluids and in all directions. Now for stress is an internal force from a unit area acting inside a solid, and can vary with the direction and its location, or its location or direction, either way, that's fine. I hope that makes things clear. Now, another thing is pressure. If you look at, let's say you have like a jar or something. Let's say there's some liquid here. Technically, the pressure is on this part, like this, right? That's pressure, right? Then if you have maybe like another solid, similar, but this one it's not. I mean, this is not hollow. This is all fixed, right? The pressure it's internal, right? I mean, it's not. It's acting inside. So I mean, for that one, okay, well, let me explain this. So for this one, this is pressure. Can call this compressive. The stress is compressive, right? It's because it's pushing against this. Now for this one, the stress could be if a stress, I mean, if load is applied, right? The stress could be this, that's tensile on it. It can also be the other way if the force is applied from here, right? It, so it could either be tensile. If it's tensile, diagram you're pressing this way. If it's this, you are sorry, my bad. This is tensile, you're pulling away. Compressive, you're pressing. Compressive, you're pressing, right? So then, by compressing, you see this, the parts are moving closing together, but this, you're moving apart. So there's tendency that this will give way, separate. While this one is will come together, of course, and it will like buckle and split out, right? So that's compressive force. It can also be shear, in the sense that if you have, let's say you have one part like this, you're moving this way, sliding across here, sliding across here. you eventually fail too. So that this will then be shear gliding. So, but for however for pressure, it's always compressive. It's always compressive, basically. So I hope this clears the difference between them. So so just to reiterate, pressure external force per unit area, it acts in all directions, and you can commonly see these examples in fluids. For stress, internal force per unit area, it's directional, but it depends on the application, on the way the load was applied. It can be tensile, it can be tensile, can be compressive, it could be shear as well, right? Then it occurs, that means they will typically see this in solids. They share the same units, but they are not the same physical concept. So it's good to understand how this applies in solid mechanics. For solid mechanics, you tend to see the word stress more, but then there are problems, maybe like you might have some discussion about pressure, maybe when you're talking about hoops, pressure vessels, basically, right? But again, there's a clear difference. I hope this helps anyone in trying to understand the difference. Cheers.